Hi, I'm Guy Harrison. I'm founder and CTO of ProvenDB, and this is a brief introduction into ProvenDB and Proofable. So, ProvenDB is a tamper-resistant, highly trustable, MongoDB-compatible database in which all changes to data are preserved and in which database state is anchored to public blockchains to prove the integrity, origin, and ownership of the data. You could use ProvenDB to store intellectual property, legal instruments to prove that database records hadn't been falsified or tampered with, or to keep a log of all document changes. The Proofable API is an API service that allows you to anchor millions of documents or digital assets to public blockchains in single transactions. And you would use this when you didn't want to use a database service, but instead had your own storage and you wanted to anchor it to blockchains. And it supports a bunch of different blockchain types: Bitcoin, Ethereum, and of course Hedera, Hashgraph. And Compliance Vault is built on top of ProvenDB, and it's a turnkey solution for end users to store their important documents, perhaps for compliance or regulatory purposes, in a document management system where the integrity of the data is backed by public blockchains such as Ethereum or Hedera. So let's talk about why we'd want to do this. And I'd like to start by taking a brief stroll back through history of how we've stored data in civilization. We've been storing data now for almost 5,000 years. This is a cuneiform tablet from 3000 BC in which some financial records, agricultural records have been recorded. Human beings use stone from time to time, especially when they want to make sure that something couldn't be altered. But for most of the time, at least in the past 1,000 years, we've used paper. And paper's been cheap, economical, easy to use and portable. And it's had the advantage that once you write something on paper, to change it usually leaves some form of trace. But of course, in our lifetime, everything has been stored on digital devices. So here's the first magnetic disk, 5 megabyte disk back in 1956. And 5 megabytes in those days used to weigh literally a ton. Here's 4 guys moving this 5 megabyte disk onto a truck. And although disks got faster and more compact and got greater storage capacity, and we moved even to solid state disks, it remains true that anything we write to a digital device, solid state disk or magnetic disk, can be overwritten, and can be overwritten pretty much without trace. And that is the core technological reason why we're having severe problems of security and trust in databases and more broadly in society. In the case of databases, we have built many layers across our data storage in order to protect these disks from being modified. So we'll take the disks, we'll wrap them in database security, we'll wrap the database in application level security, network security layers, and perimeter security firewalls will be added around these disks in order to make sure that no one can get through. But of course, hackers routinely break through all of these layers and get to the data on underlying disk. And there's always the chance that there's some insider in the organization who has unrestricted access to this data. So it's an open problem. And more broadly in society, we see that digital tampering is rife. We read almost every day about someone who's manufactured data, fake news, false news, deep fakes, document tampering, manipulation. These things are all part of everyday life and have led to a disturbing loss of trust in information in our society just when we need trust the most. So of course, most people in the DLT community believe that blockchains or digital ledger technology is the technological solution. They are, after all, immutable and tamper-proof. But of course, a DLT, even one advanced DLTs like Hedera Hashgraph, cannot replace databases. They just don't have the same performance characteristics. They don't have the sort of storage capacity, schema and data models, query languages, and the developer productivity for building sophisticated applications on these platforms is missing. And so this is creating a dilemma for us. We either use a database and sacrifice immutability and tamper detection, or we use blockchain and sacrifice performance and economics. And you see this dilemma playing out all the time in our society. So that's where ProvenDB comes in. ProvenDB bridges the gap between databases and blockchain. ProvenDB is a MongoDB compatible database, and data is in fact stored in MongoDB, but whenever changes are made, we keep all the different versions of that data. And periodically, we anchor the database state to public blockchains using Merkle trees and other sort of cryptographic mechanisms so that we can prove the state of the database at any time. Any unauthorized tampering of the database will break the blockchain proof signature, and you can always extract database proofs and use them to prove the origin date or ownership of documents. Proofable is an API service that separates out the database storage from the anchoring and allows you to anchor your own data to a public blockchain. Potentially millions of digital assets or documents can be anchored in a single API call, and you might use Proofable if you've already got your own database or you've got data stored elsewhere, or if for whatever reason you don't want to adopt the database model of ProvenDB. And Proofable supports Bitcoin, Ethereum, Hedera, and has a command line interface as well as SDKs for Go and Node and others coming soon as well, and a generic gRPC interface. So that's Proofable and ProvenDB. I hope you've got time to have a look at the online demo that accompanies this video. If you want to learn more, visit us at provendb.com or proofable.io. Contact me directly if you like. My details are just down there. And I hope this was interesting and useful to you. Thanks very much. Bye-bye.